Hello everyone, so I'm going to bring you through the first example of electrolysis, and this electrolysis is of a molten ionic compound, molten meaning liquid, right, with inert electrodes. And when it's inert electrodes, we need to remind ourselves that this means that it is unreactive. It will not react with the reaction. Okay, molten sodium chloride will therefore only have Na plus, right, liquid, and Cl minus liquid inside the liquid here. Okay, so this is the electrolyte, and the electrolyte will only contain Na plus liquid and Cl minus liquid ions inside this. Okay, so since this is the first example, so let's go through this a bit slower. So when I look at my setup, I must first label the battery. Okay, we must always remember from our lower sec signs that the longer terminal is the positive, the shorter terminal is negative. Okay, that's the first step. Okay, label the battery, step number 1. After that, we need to label the electrode. If this is negative, this will also be negative. If this is positive, this electrode must also be positive. Okay, so battery positive connected to electrode positive. Battery negative connected to electrode negative. Now, you might not remember this from lower sec science, but from a battery, the electrons will come from the negative side. It will enter the electrode, and then it will go across, and then from the positive, electrons will go up again. So then you might ask, Mr. Benjamin, how does the solution conduct electricity? The solution conduct electricity using mobile ions. So mobile ions will flow, right, in the electrolyte, but at the top here, in the copper wires and the electrode, it is mobile electrons. So you must understand that there's a difference in the way electricity is conducted in the circuit. So I repeat, step 1, label the battery. Step 2, label the electrodes. Step 3, electron movement from negative to the electrode and then from electrode to positive. Okay, all these are all very important. Okay, next, what's the next step? So next step, I need to identify all the ions present in the electrolyte. And because over here is a molten sodium chloride, the things present in the electrolyte is just Na plus, liquid, and Cl minus. Okay, that's all, right? So where do they go? So Na plus is positive, so it will be attracted towards the negative side, and then negative ion will be attracted towards the positive electrode. Okay, so let's take a first example. So positive electrode, we know the chloride goes towards the positive electrode. There's nothing else in the thing, so I do need to choose. So the half equation will definitely start with a chloride, and this must be a liquid. Okay, so now we must think, what other things do I know about chloride? What will they form? So make sure you just leave a nice blank. So you must think chloride will become chlorine gas. Okay, chloride becomes chlorine gas. Then after that, what do? I try to balance. Oh, there's 2 chlorine here, so I add a 2. And then you must not forget that there is a negative sign here. On the right side, I got 2 negative, right? I got 2 negative here. On the right side, I got 0. So in order to make sure that it is balanced, I need to add 2 electrons on this side, so that both sides of the equation has 2 negative charge. Okay? Both sides have 2 negative charge. So this is my complete half equation. So let me check. Is it true? At a positive terminal, do I give out electrons? And that's true. At the positive terminal, you see, it gives out electrons. The electrons leave the terminal. I lose electrons. So over here is I lose electrons. And we must remember oilrig, O-I-L-R-I-G. Oxidation is lose electrons, reduction is gain electrons. So what is happening on this side is this is an oxidation reaction. Okay, because I lose electrons. So I need to describe what do I see. Well, I see bubbles, right, of yellowish green gas. And then you must describe what is the test for chlorine, which is basically damp blue litmus paper, turn red, and then bleach. Okay, so that's bubbles of yellowish green gas. And how do I explain? So your explanation is actually very important. So let's practice one here. So we say that at the positive electrode, right, at the positive electrode, chloride ion is oxidized to form chlorine gas. Okay, chloride ion is oxidized to form chlorine gas. So let's look at this. So what is important in this? So let's highlight this. This is the location. Let me write in blue. The location, please remember, at the positive electrode. Then what must we have? We must have the reactant. The reactant is the chloride. What else must we have? We must have the reaction. And then over here, we must have the product. Okay, so that's how you explain. At the positive electrode, chloride ion is oxidized to form chlorine gas. Is that okay? Alright, let's look at the other one. So now we have said that at the positive electrode, chloride ion go there. At the negative electrode, the Na plus will go there. So let's write first Na plus, and it's a liquid state. Then I draw the arrow slightly further away, and then I think, what can I form with Na? So over here, I form Na, either solid or liquid. Most likely it's going to be liquid because it's going to be very, very hot. Alright. So then I think, do I need to balance? Or no, it's balanced. On the left side, I got positive charge. On the right side, I got no charge. So I want to be them to the same. So I add 1 electron on the left side such that the equation is balanced. Okay, based on the charge. Okay, so over here, you must notice that this guy gains the electron. So because it gains oil rig, this side is a reduction. Okay, so let me check, is it true? Did I gain electron? Yes, I gain an electron. See, the electron enters the electrode. I gain the electron. So I describe what is sodium metal. So this is a silvery liquid form. Okay, but you should know that actually sodium is actually very, very reactive. So this is very, very seldom because it's very, very hot. So we need to make sure that there's no oxygen at all, or not the sodium will immediately react. Okay, this is very, very unlikely. Okay, and the explanation, remember what I said just now, location, reactant, reaction, product. So now the location at the negative electrode, reactant is sodium ion. So sodium ion and then the reaction is reduced to form sodium metal. Okay, so again, location, reactant, reaction, product. Right, so this is the first practice where we are doing the electrolysis for a molten ionic compound. And I hope you go through the step-by-step thinking process with me such that it will be clearer for you. Okay, so all the best. Let's see you for the next example.